Currently, I have noticed a couple of applications who do see when you get a port down if the node itself is down and not do that processing. But this honor should not be on an application. It should be something that can be intelligently done somewhere before this event was dispatched itself. And then you have the infamous packet ends that you have. Like imagine when you're going on a road trip and there's this one guy who always keeps asking, "Are we there yet? Are we there yet?" Right? So we don't need that. So if we are getting ARP requests, like way too many ARP requests at a one particular time, so that's not needed, and it sometimes hogs the system and leads to things which we can avoid. So the possible events that we dampen. Toggle events are the primary targets for event dampening. So which are typically your interface up, interface down, node up, and node down. So these things can be significantly optimized, and these are the prime targets. And so this is something which I say comes as very obvious knowledge when you're trying to when you're programming with any kind of events. Same thing with the packet and burst prevention. All right. So the framework that we thought of, it uses the Genius Datastore Job coordinator. It is a new layer on top of the job enqueue mechanism. So those who have used the job coordinator enqueue a particular job. So now these are the jobs that I'm talking about, a port up or a port down. Then you enqueue a different job on top of that. So before this job is gone into the Datastore job queue, we have another queue of our own, a queue of our own basically. Now where these jobs are maintained for a particular configurable period of time, and as these are aged, if a corresponding nullifying event occurs, then we do not report both of the events. So what happens is, like, you got a event, you put it in your particular queue, and then there are various dampening functions that are monitoring this queue and working on it. So those will be covered later. So you got a port up, it's still in this queue, and within, let's say, 5 milliseconds is your threshold. You got a port down and another port up within those 5 milliseconds. So you do not report the second port down, port up, because ultimately it did not change what had happened. Then applications are free to choose the usage of the framework based on their requirement. Like if an application requires to know each and every event, then it does not need to use this. Or it can be very, very application dependent. Like interface manager events want to be dispatched in a dampened way, so they can do that. Some other one does not want to use it, so it's a different API basically. Okay, they can define the kind of dampening they want, and normal events are isolated from dampening prone events. And obviously this will lead to better utilization of resources. All right, so very obvious benefits that come out of this are a configurable exponential decay mechanism for events. So for those of you who are already aware of any kind of event dampening would know that let's say interfaces gather a reputation over time. Some interfaces are really bad, they're constantly flapping, so you give them a penalty. And once that penalty reaches a particular threshold, you stop listening to those interfaces at all. So we want to provide a framework which gives these kind of mechanisms and makes it available. Flexible selective dampening based on event type, again, similar example to the first one. Improved convergence time and stability. Disturbance is reduced, network, it's more scalable. And so again, these are very, very obvious benefits that you get out of it. So better utilization of system resources. Then we talk about where we have done it and the possible places to do it. So Faseela, would you like to come in? Yeah. Uh, yeah. Yeah, so that's exactly the question where it is actually. So you want to dampen it at the plugin level, or you want to dampen it into the interface manager. So if you are in the interface manager, you are already kind of logging this information in the queue that we have. Like there's a temporary queue, right, where we are trying to do this dampening function. So you have these events there, and you want to do some analytics on top of that. Yeah, that should be possible. So a framework is, the whole point of the framework is to be extensible in a way that others can use it for and extend it the way it's required. Right? Does that answer your question? Yeah. Hmm. Yeah. Yeah, so that's what. So that is ultimately what is happening from a subscriber point of view. But you don't have to throw it away. You can put it and store it into some place, and you can assign scores like what I talk about penalizing a particular interface. So you can maintain your own data structures where you are having this reputation of a particular interface, right? Uh, yeah, so you could do it at the plugin, you could do it in the interface manager, you could do it even further up north. Like as I said, some applications are already doing it. Like they don't process certain events if they know it's not relevant for them. Yeah. True. Yeah. Hmm. Yeah. True. All right. So then we talk about the Datastore Job Coordinator. Please welcome Faseela on stage.
Okay, one more thing I wanted to tell here actually. Coming to the thought process where we started with this event dampening framework, actually, when we were testing our L2 VPN and L3 VPN on network VPN service, there were two, three major issues which we faced. One was this port flapping. We were unnecessarily processing all these events and all applications. And one other problem which we were not able to really solve is there is no mechanism to identify a control channel disconnect versus an actual node shutdown. So what happens is if the control channel is flapping, that is the channel between the controller and the switch, if echo request reply times out, which results in a node removal event to the applications. So in that case, due to this MDSAL data tree kind of structure, what happens is once the node is removed, you get notifications for all node connectors also, that node connectors are also removed. That is, once the parent is removed, you get notification for all children. So what happens is, ideally that should not have happened. We are getting only node removal, but in effect we are getting the node connector removal events also, which applications start processing. So there is no way currently in the OpenFlow plugin. Anil Muthu, you can just correct me if I'm wrong. When we are listening for the inventory operational events, we don't find any proper mechanism to distinguish between these two events. So finally what happens is, we get, if the channel is flapping, you get node connector removed events, that is port removed events, and then port added events, back and forth like this. So that is one primary reason we wanted to come up with a framework. So initially we thought of doing something on the OpenFlow plugin level, so let us dampen it there. Then what happens is, some of the applications, for example, interface manager listens on both inventory and topology models. So we need both OpenFlow plugin and OBSDB plugin. So we wanted to come up with a generic framework which can be used anywhere. Either we can use it at interface manager level or at the plugin level. If OBSDB plugin wants to use it, let them use it. If OpenFlow plugin wants, let them use it. So we wanted some framework like that. Then when we analyzed, we figured out, okay, the Datastore Job coordinator, whatever is already there in Genius, so it has this queuing mechanism where the jobs are queued and then processed based on the job key. If you have the same job key, it is processed sequentially. If different job key, they are processing it parallelly. So we thought that is the right place to put this framework, so that whoever wants the dampening, they can use that new API with dampening support, or else they can use the current existing job queue framework. So what this Datastore Job coordinator does is, so mainly it was introduced for having parallelization between multiple jobs. For example, you are processing multiple interface up events, they don't have dependency between each other. If there are two interface up events coming, they can be processed parallelly. If there is a port removal and add coming for the same port, you need to process it sequentially. So this framework provides such support. So a Datastore job, it means a set of updates to the config or operational data store. So if you have any dependent jobs, that is the result of one job is needed for processing the next one, you process it sequentially. Else you can do it parallelly. This framework is very well in place and currently used by many of the modules in Genius repo, as well as the network VPN service. L2 VPN, L3 VPN, everybody is using it. So it's well proven. So we are introducing one more layer on top of this, another API in the same framework, which will have this dampening support. So you will find enough documentation of the same thing, I think, in the Genius wiki. So I'm not explaining more on the Datastore Job coordinator part here. So what happens is, when there is a interface flapping or this DPN disconnect or even the packet in burst, if somebody is using this Datastore Job coordinator, we are unnecessarily processing a lot of events which are really not needed. So we are planning to put this dampening framework in the same module so that the existing stress is reduced.
So this framework comes to picture once the data is done to this country. You get a notification. So whatever notification will come, you'll work that damping on those notifications.
Okay, so currently how it works is, suppose you are listening for the inventory or operational events. So you are getting the event. So if you see the interface manager design currently, you receive the event, and then whatever you want to process based on that event, that is a worker thread, which is enqueued. That job is enqueued using Datastore Job coordinator. So the Datastore Job coordinator will have for one particular job key a queue. These jobs will be enqueued there and taken one by one and processed. Event from southbound.
Southbound in the sense you are directly listening for a YAG notification, or you are listening for a data queue notification?
It is data tree change notifications.
Or listening on a data
Listening on events. This not this Datastore Job Coordinator, but the applications who uses this Datastore Job Coordinator. Datastore Job Coordinator just takes the jobs and execute it. That has no dependency on the southbound events. That does not have any dependency. Yes, yes. Whoever wants the dampening, they will be listening for the events. They get it. They queue the job using Datastore Job Coordinator. So we have added a new NQJob API which has this dampening support. So applications are free to choose to use or not to use this API. If they don't use this new API, they will get the existing functionality where there is no dampening. You queue whatever events you get and it will be processed one by one. If this dampening is in place, you have a dampening function before the actual queuing happens. So only the events whatever survives this dampening function will actually process the jobs. No, Datastore Job Coordinator is a generic framework. If you want to use it at OpenFlow plugin level also. Yes. Yes.
My point is you give this input to this engine and then it processes. So how you generate that input is my question. Whether it's directly from a southbound plugin or the data store. So it looks like your everything is written into data store.
Yes.
You get the events from there. You create a job and then you submit it to this
job coordinator. Whenever it is time to process, that thread will be called.
Yeah,
okay.
It's like all the events are anyway generated.
Yes.
Dampening is not at that point. Dampening is at the time of execution.
Depends on where you are using this framework. If you are using the framework on the OpenFlow plugin, you will not even generate the event, right? Inventory events you will not generate.
Integrated into the job coordinator because that is the common point where, like, say, all the applications are currently using the because typically we get a notification. Most of our applications are of the model where, like, say, somebody application A writes to the data store, B gets a notification, B again writes to the data store, C gets a notification. That's how the chaining happens. Right? So the common point where this is being put now is, like, say, as it has been integrated as part of the. We already had a data store job coordinator, which was doing mainly a different job in the sense in that what it was trying to do is you get a notification. We know that all our data change listener or tree change listener, whatever is the actor at the end of the day, an akka actor. So it will be serial one by one. Now, like, say, for example, I get say 10 interfaces change at the same time, or, like, say, all the events are queued up. Now I process the first interfaces process. The second interfaces processing will happen only after the first interface processing is complete. Right? So the Datastore Job Coordinator was originally introduced in order to bring some level of parallelism there. In the sense, if my processing of notification 1 does not have anything to do with notification 2, should I wait for the notification 1's processing to be completed before I can pick up and do this? So basically, Datastore Job Coordinator, what it does is it takes a job key, which is primarily for example, I mean, if I take the interfaces, the interface ID or any identifier which uniquely identifies the interface becomes its key. And any events or the changes, the change notifications which happen on top of that key, it gets ordered. But then across the interfaces, it can happen parallelly. But on the same interface, the changes will be, I mean, the notifications will be processed in the same order. So this was the original purpose of the Datastore Job Coordinator. So what is being done in this context is to add the dampening mechanism as part of the Datastore Job Coordinator, but we can always refactor it, pull it away from the Datastore Job Coordinator and probably integrate it with the OpenFlow plugin.
Yeah. So that's my problem. That's my problem is the concern that dampening is always is a contextual activity. You need to have a context of what events is coming, and then you can dampen it, right? There is no general rule of making it dampen that any message that come, I can put a generic algorithm that actually is going to dampen it, right? So you always have a context with this. So if you do it in a genius level, right, which basically is not a RAG, it's basically at the application layer, right? So you need to have a context. Now, as of now, we are just concentrating on an open flow, that is fine, right? But let's say somebody wants to do it for a VSDB or the netcon devices when they support the notification and all those things, right? They all have their context, and you differently dampen all the events coming from the different devices, right? So that's where I think is happening in a edge level is a correct position. But the framework is something, if you are writing, it's good to have that framework that you can plug in anywhere at that, edge. So that kind of framework will help that, okay, there is a framework, but if you can hook it into an edge level like OpenFlow Java library or OVSDB encoding decoding library, if we can hook it at that level, that kind of framework actually will help.
So what will be the right repository to have this framework?
Yeah, you can.
That is the one thing which now it creates a reverse dependency between the plugin to Genius.
No. So that's where.
Is something which
so it's like you can spawn it and put in offset one project, right? Because
Genius
it's not
is already
offset one, right? So offset one you can put it, and this can be a separate project, right? So it could have interfaces that if somebody want to put a dependency on this, they can hook that framework into their system, right? So all the offset one project kind of use that, so everybody can have a dependency on this, or it can go to offset zero also as a dampening, thing. But the point is moreover is a protocol layer, so it can be a separate project. If project want to use it, they can hook it, otherwise they can leave it, kind of thing, right? So Genius is like a one level up, right? So now that is basically a service, not a protocol. If service is there, and then you are assuming that the service will take care of the dampening, which basically can work, but the problem is you're unnecessary, delaying the damage till the service level. You can keep that damage at low level. That actually will give you a better performance, better stability, and all those things. That's the purpose of having the dampening, right? So we can dampen it, so it can done less damage to resources, stability, execution logic, and everything, right? So you put it at the low layer. So that's where I think it will be more useful if you put at the edge level rather than at the service level.
I think the whole of Datastore Job Coordinator is such a utility, right? Everybody can use it, yeah.
Not that way, because his point is totally different. So see, I have a data store is the heart of everything, right? You are now putting a gatekeeper of the data store. Protocols sit outermost edge, right? Any damage causing things should be eliminated at the gate. We will not let a thief, if a thief is say actually kicked out from the gate, it is much better rather than letting him cross the gate, come all the way to my door, and then say I kick him out.
Yeah, but in different place, what level of for example, for analytics maybe you want to log all the events associated. At that level you will allow. And at a higher level you want to stop those.
No, and logging or analytics purpose you can hook it anywhere.
It should not be tied to any specific reason of utility or service that you can apply depending upon your needs. You want to stop all the unwanted events at the very bottom layer, you can apply that to say plugin itself. Or if you want to do it at the higher layer, you will do it at some other.
No, my point is the whole context of dampening is dampening the event, so it actually create less damage to the system. Now the point is, if you kind of move it to the higher level, you actually defeat that purpose, right? You are basically, what you are saying is application should not suffer from these kind of event because they are coming very frequently, and it's very unnecessary for the application to process them because you have to execute the same logic again and again. We want to avoid those kind of scenario, right? If you want to cater the these kind of event, then you don't really have to dampen it. Let it go to the application, and application also can do it, right? So you want to minimize the whole impact on the stack. That's where I'm saying, these are unnecessary event. You can log it at the edge level also, that what kind of event you are coming if you are really interested in the history or network analytics of those events. But sending it up on a stack is basically, as you go up, it actually start defeating the purpose of the whole thing, right?
Going up and down, that is one event. And on top of that, you have 10 interfaces. And the different interfaces going up and down may be of different interest. You may want to allow that interface post up-down event to reach the interface manager, and interface manager takes the decision what interfaces on top of that open source code we want to drop.
Mhm.
Right. So I'm not saying that it should not be clear, but depending upon the need or
Yeah,
you
so
may
that
allow to some point and then you dampen here, or if you don't need some events, you block it at the very bottom.
the context here is, I think, is totally different. What I understand the problem is, if you get a port up and down and up and down 2 times, right? You want to dampen it. You want to make it one event, okay? And that can go to your interface manager, and then interface manager can decide what all need to be done, right? But are you okay if you start getting both of these event to interface manager and you execute the same logic of what interface need to be disabled and enable? You're going to execute the same logic twice, right? That's where the dampening is. You dampen it to one event because there is no point in sending the same 2 event again to interface manager and interface manager act on it twice, right? That's the first level of dampening, right? Now, once you send the first level of dampening, that is a protocol dampening. Then you go up and there is a service level event that you generate using this event, right? That you can do as service level dampening because that is moreover contextual. So these are the separate thing that you have to do. You can't really merge it in the one thing. You do the protocol level dampening, you get an event, you generate more event, and then there can be, these kind of event at a service level that you again want to dampen, right? That is a contextual in the service level. So as each service can kind of have its own framework and they can dampen these events, they know that it doesn't make sense to kind of react to it, or any consumer that is consuming this service, there is no point in kind of sending these events to them, we can dampen it. So that dampening will be very contextual to the service that you are writing, right?
So the edge.
DJC comes into picture. The job coordinator will use those services at different levels.
Yeah, so that's where
you can use this dampening so that a service wants to use dampening, and if service is using the job coordinator, it can say, okay, I want to dampen.
Yeah, so the way I see is you basically trying to do both of these things at that level. Okay.
Anil wants
So-
DJC in an offset zero
Yes,
project.
So actually speaking, I mean the edge,
Right.
like what Anil mentioned, the edge dampening and the core dampening or the service level dampening are two different things. One is like, say, this requires a different set of capabilities, that requires a different set of capabilities. Now, there the contextual information based on which what to suppress, what not to suppress is best known to the application. Whereas at this level, I mean, it can be a very generic set of rules. So, I mean, if we improvise the framework in such a way that it addresses both the cases, but sometimes too much of abstraction is also dangerous.
Yeah.
Too much of abstraction is very, very dangerous. So sometimes it is better to avoid it. But I mean, as much as possible, both should be there so that the system is protected.
Yeah, exactly. Both need to be there. Now the problem is what you are doing. If you do it in a way that you do the protocol level dampening and then the service level dampening, that will actually boost your performance. Because what happens is, as of now, you are actually getting all the events, right? Even the 2 port down is coming, you are still getting it to the data job, the Datastore Job coordinator. And that actually then take action whether it need to be dampened or not, right? Still you are processing all those things. Now you do protocol dampening, you avoid unnecessary traffic to a data job coordinator, right? And then data job coordinator will have a less set of thing where it can run the dampening algorithm. Any algorithm will have, let's see, I would say there is no dampening algorithm that run on O1. All the dampening algorithm, the optimized one is ON, where you reduce your N, your complexity and time to dampen that event is going to be quicker. Okay, so you have to reduce that N, and that N can be reduced by dampening all the event at a protocol level. So you reduce your N, so your dampening algorithm will work faster. Because you don't again want to defeat the purpose of running a dampening algorithm that actually start consuming your CPU, and that actually there is no purpose of having a dampening, right? Because the event processing probably could have been faster, right? So it's a trade-off. So these dampening algorithms sometimes don't get traction much because of their consumer, because they look at a large data set and they start giving processing and computing problem, and the second thing, they start giving you false positive results. Okay, you dampen a wrong event because you are processing in a parallel and try to parallelize it, optimize the algorithm heavily, and when you start implementing it, implementation and algorithm has a very different view. When you implement it, you always end up with a bug, so you start giving you a false positive. If you get a false positive, your system is not stable enough. False positive is a bug, right? So yeah, it's had a trade-off. So you need to make sure that whatever you do does not consume the CPU if you process the event, it can consume X CPU, but you use the dampening algorithm and dampen the event, but it consumes 2X CPU. There's no point on having that kind of system, right? So I think, yeah, that's where having two set of dampening at a protocol and service, I think will be, much better approach.
Okay, so this was the proposed implementation. So we will have the current queue in Datastore Job Coordinator. If you see, there is a job key based queuing. So each queue will have jobs based on the same key. That is, whatever is to be processed sequentially will be part of the same queue. Now we are having a dampening queue before this with a dampening function implementation. So whatever survives this dampening function level only will go to the actual job queue. I think Muthu, you can explain about the dampening functions in detail.
Yeah, so this is mainly about the implementation aspect. I mean, it is part of it is only in place. I mean, I don't think, the complete implementation is in place. So the three options which we are thinking for implementing this is, like, say, implement some sort of a decay function, which will certainly have only kind of at least ON or O log n kind of complexity. It's more like a half-life decay in this thing, no? I mean, the radioactive elements. So an exponential decay function is one thing which we are thinking of, and or the penalty or reward based approach, which is I think, currently the Datastore, MDSAL Datastore is using a rate limiter from Guava, right? So we are thinking of using that with the set of, the event classification mechanism, so that, we can associate one rate limiter each and find out. Of course, these have to be tested out for the false positive scenarios, because it has not been stressed to that extent so far. So those are some of the implementation approach or the low level designs which we are contemplating on. But you are going to do some sort of a code walkthrough, or okay. Any questions? Yeah. Yes.
It is told that a higher level that node is some node is changed or node is removed. Means for the channel flapping.
Yes.
So how currently it is handled if that event is not registered in data?
I didn't get your question. Is it specific to this context, or you are generally asking, like, say, how exactly it is handled?
Yeah, generally like OpenFlow plugin. So for OpenFlow.
Yeah.
Actually, as she explained, some of the events are not registered in the data store, or might be like channel flapping is registered as a node removal or interface flapping.
Right.
Right. So this is not exactly we are getting what event means. Exact event like the channel flapping. So how currently it is handled?
So currently, since there is no dampening function, all these activities or the events which are detected from the plugin level, they all translate directly into the data store operations. The problem is not with that. The problem is the latency with which the applications can react to it. Or, like, say, for example, you imagine a setup something like this. You have the controller, you have the switch, you have some L2 switch which connects these two guys. Now that L2 switch is in a HA situation. They have an active standby kind of connection to transparently let it connect to the controller, right? It just go and just reboot that switch. So what will happen, like, say, there is a possibility that you will detect a disconnect at the plugin level, and at a very, very rapid pace you will see, there is a connection event also coming. Now, when I actually get the disconnect, applications have their own logic in order to react in some way.
So let us assume that they are executing. At time t0, you sensed a disconnect. You sent it to the data store. At time t1, applications receives it. Applications process the delete event from the data store notification from t1 till t4. Now between t1 to t4, before the application start completing the reaction, now like say at time t3 parallelly you are getting a connect event also, which again goes and then updates the database. Of course, that event will be handled in an ordered manner to the application, but then now the applications are processing the events which need not have been processed, right? I mean, so that is the main purpose of this. So currently, since there is no dampening mechanism or this kind of logically suppressing or handling that kind of frequent flaps, it directly goes to all the applications. It goes and updates the database. Like? Yeah, that is what. So now like say, okay, so this is where the rubber meets the road. Now like say I have 20 applications. Do we want, I mean, 20 applications to put this boilerplate check everywhere? That is one way of looking at it. The second way of looking at it is probably it may be necessary. I mean, this is how we actually address the issues. I mean, whenever we are reported with such critical issues, I mean, that is how we address it. We put the logic saying that, okay, I mean, deduplicate it and stuff like that. Now, the intention is like, say, for example, can we actually try to commonalize at least a set of applications which can actually benefit from it, or what is the common way of addressing it? So that is the, I mean, the main driving point or the motivation for this. Yeah, that is the main intention, because like say, see, any outlier should be kicked out, like say as how in a very detailed way Anil explained, any outlier, any rogues must be kicked out at the edge, so that I mean you don't let the damage propagate all the way higher up the layer, eating up the resources, right? So, and it will be also relatively more simpler to do it at the edge, because you don't have to, you are forced not to think about a lot of logic in terms of like say kicking out a packet in. The best thing you can say is like say this packet in is somewhat duplicated. I have only one detection rule to do. If I try to do the kick out or the elimination much at an application level, I have to put a bunch of rules in order to eliminate a particular outlier. So yeah, I mean this mechanism has to be both at the edge as well as the core. Both are different in a different context. At the core or at the service level, its intention of eliminating could be totally different, because there can also be a possibility that there is a event amplification, right? You get one event from the edge. At the service or the application level, it gets multiplied into 10 events. Now, that justifies why a service level dampening is required, right? Whereas, I mean, I am getting a frequent one-off southbound events itself without, I mean, it's a 1:1 mapping. I mean, it's a packet in. For example, I mean, you got a packet in, you detect that there is a, I mean, you have to provision X number of flows in Y number of switches. You are provisioning one by one. Now you have provisioned only one switch. That does not mean that, like say, I mean, you will not get a packet in, right? Because before you provision the second switch for the same packet in, so that the entire pipeline is taken care of, the second switch, this guy would have processed it and forwarded it to the second switch would have done a table miss and he will punt the packet, right? So this can happen in the sense, at the edge level, there are certain situations in which your dampening is required, and at the service level, it is typically at the, whenever there is an event amplification involved, right, between the edge to service. So both the levels it is required. That is what the main stress point is.
Yeah, I mean, is it like, say, I mean, we can implement something like a simple exponential decay function and then, like, say, pass through this, or I mean, we have to actually, if why to reinvent a wheel if the rate limiter of Guava is working better. So these are the two options which needs to be evaluated. It's not going to dampen the event, it is just going to suppress it. I mean, we need to add a lot of sauce on top of it in order to make it work like but it doesn't also serve the purpose. Exactly, because yeah, I mean, because it's some of these Guava libraries we did have a problem. I mean, if we had this delayed cache for some other purpose. The problem is, I mean, you have this expiration cache, right? Self-expiring caches. The problem is, I mean, it doesn't expire exactly at the time, naturally. I mean, because of, I mean, you might load gazillion of entries and then it need not actually eliminate it. And it assumes that the applications can tolerate, like, say, the long living nature of the data. So like that, we do not know how many traps are there in the rate limiter. But I mean, at least we thought that, like, say, it is being used by the data store. Maybe, I mean, if we can build some capability to bring the dampening mechanism, we can use it. Otherwise, it is not very hard to write a simple exponential decay function and then pass it through that. Typically what the routers and I mean, those guys have done it much better than us, right? So those are the two things which needs to be evaluated. I mean, and then I'm probably planning to push it to push a Jared on this for the review. Yeah, that is true. We can actually put it in an offset one project, in any of the offset one projects.
I think this is a good starting point. So if this is Genius, I would say this. I think it's something which we first have to evaluate, right? Whether it actually works or not.
Yep.
That's the first thing. If it works, then the next thing from is, if it works, then it's good to kind of other projects use it because it's overall going to help everyone, right?
Yeah.
And then comes whether this functionality can be taken out of Genius or the part of it that can be taken out of the Genius and use it at offset one level kind of thing.
Yep.
So yeah, that's some later on. But first we need some prototypes, some results out of it to kind of make sure that approach to it.
Yeah, as see, the only point is, I mean, if we can at least have a for example, I mean, if this suppressing function, it need not be part of, I mean, if we have to refactor it and then say that, I mean, edge and the core, right? So we can find out whether if we integrate it with the edge, whether it works. Because, like, say, putting two problems together is like, say, stacking two problems and looking at this from this side. I mean, I do not know whether this guy causes the problem or this guy causes the problem. So if we can refactor it and then, like, say, whether it is being pushed as part of the I mean, Genius or I mean, the plugin, if we have a draft Gerrit which can actually integrate it with the OpenFlow plugin and then just do the basic testing, like, say, for example, eliminate all the applications, simply create a scenario wherein there is a heavy slurry of packetins, or, like, say, I mean, a port flapping situation can be emulated. And at the inventory level, I mean, if you are seeing that the dampening function is working, then it has crossed its first qualification level. Second thing is, like, say, then we will add it as a service dampening functionality. Then now we have a edge dampening plus a service dampening integration. Now we take a real application use case, stress it again, and then find out, like, say, whether this is both the guys are working properly. I guess, is there anything else which you are thinking of, Anil?
Dependency on a Genius code just because of the different damping.
This will be a circular dependency.
That you could do independently using particular genius functionality or level functionality.
So that genius level, the events depend damping, that you can do in a genius part of it. But I think each protocol needs to do some level of damping down there, otherwise,
Yes.
otherwise the whole logic that you're writing this framework up, that's going to cost, it's like
It's going to be counterproductive for its very purpose. Yeah.
So it just needs to be designed in such a way you don't end up adding dependency on a project that you
Okay, I mean, that's what we were discussing. I mean, before, I mean, at the beginning, sometimes too much of abstraction is also dangerous. Yes, yes, yes. Exactly. So if it is more like that utility, then it is fine. But I mean, how much of the functionality can be carved out is something which we need to work out. So that, I mean, it can be put in such a way that, because if you see the infra, I don't know whether, like, say, infra util, will it have a reverse dependency on other modules? I don't think so they have. So it should be only to that extent. I mean, it should be limited. Oh, is it? Okay. Yeah, so I mean, I think this is what we mentioned. I think, I mean, a CEP introduction will be too much, because, like, say, again, we will bring up its own baggage, and we do not know which open source CEP will have the problem. So probably, I think, as writing a second option will be something which is more practical. Guava rate limiting, again, we need to do an evaluation. Probably 2 and 3 we can zero in on, and then probably we'll choose 2 as a implementation mechanism. Right? What is this? Control channel flapping. You want to explain? Yeah, that was the use case which you are explaining, right? That's it.
I missed out the last 3 slides. I mean, I thought that is the last slide. Okay. Help us the response. Thank you. You have to disconnect this. Okay. Okay, I'll have to rest there. Thank you. Thank you.